Imagine trying to instantly blast the data of an entire 4K Blu-ray movie across the length of an entire football field.
Hmm.
And doing that every single second through a copper wire that's like no thicker than a pencil.
Right, because standard HDMI cables just tap out after a few feet.
Exactly. So today on this deep dive, we're looking at the invisible tech keeping massive sports bars and corporate networks from just going entirely dark. We have the spec sheet for the Kramer EXT3-XR-TR HDMI extender.
It's quite a device.
It really is.
Okay.
And our mission today is to figure out exactly how flawless 4K video travels 330 feet without losing a single pixel.
Yeah, the physical reality of these specs is just wild. I mean, pushing 4K video at 60 hertz over a standard SeaTac copper cable up to 330 feet or 100 meters is a monumental engineering challenge.
Oh, I bet.
Especially when you factor in that it's transmitting in full 4.4.4 color space.
Okay, let's unpack this for you real quick because that 4.4.4 spec means zero color compression. So if you're projecting a dense financial spreadsheet in a boardroom, 300 feet away, the text won't look blurry or artifacted.
Exactly. It stays razor sharp.
But stuffing all that uncompressed data over a basic twisted copper wire just sounds like the ultimate bottleneck. I mean, it's like trying to blast a fire hose through a drinking straw. You're talking about an 18 gigabit per second pipeline carrying HDR10 and totally uncompressed Dolby True HD surround sound.
Right.
How does that not just immediately choke the cable?
Well, what's fascinating here is how the HDTV 3.0 standard actually handles the signal on a microscopic level. So instead of sending one raw bit of data down the wire at a time, like a single car on a one-lane road, it uses advanced modulation.
Wait, modulation? Like changing the wave itself?
Yeah, exactly. It alters the amplitude and the phase of the electrical signal so it can stack multiple bits of data into a single symbol.
So it's essentially taking that single car and replacing it with a high-speed, multi-level bullet train on the exact same track.
That's a great way to look at it.
Or, well, to stick to the plumbing analogy, it's like taking fire hose water, freezing it into these perfectly organized, ultra-dense ice blocks, sliding them through a drinking straw, and instantly melting them back into water on the other side.
That is the exact mechanism, yeah. It ensures all those ones and zeros arrive at the precise microsecond required, which maintains absolute signal integrity over that massive distance.
Okay, so that makes sense for the video, but here's where standard networking logic seems to break down for me. You're already stuffing 18 gigabits of heavy video data down this copper wire, right?
Right.
But looking at the specs, this Kramer device also extends a 1 gigabit Ethernet connection, USB 2.0, 32-channel digital stereo audio, plus bidirectional IR and RS-232 control.
It's a lot of data.
It's a ton. So what does this all mean for you if you're outfitting a massive sports bar or a corporate network? Like, if I move a mouse at the remote terminal, how do I not hit massive latency?
Well, it's because HD Basic doesn't rely on standard packet-based networking like your typical internet router does. A router processes and routes data as it comes in, which causes delays.
Oh, so it's not queuing things up.
No, not at all. It acts as a synchronous protocol, so it allocates highly specific, rigidly timed slots for all that extra data right alongside the video.
Oh, I see.
The video gets the bulk of the train cars, but the Ethernet, USB, and control signals have their own dedicated, unblockable VIP cars on that exact same train.
So a mouse click never has to wait in line behind a frame of 4K video. It just slides right through.
You got it.
And that RS-232 spec, we should probably translate that into real-world value.
Huh.
We're talking about legacy serial ports that allow a central AV system to physically turn the remote projectors on and off, drop the motorized screens, and, dim the room lights all from that one single wire.
Right. And if we connect this to the bigger picture, the true value here is that bidirectional control. You are operating a remote display 330 feet away as if you were standing right next to it.
That's wild.
You plug a camera into the USB port at the display end, and the computer on the other end of the building instantly recognizes it. And what stands out to you about trusting your entire network, video, and control system to one single copper wire?
Honestly, it's that it just works. And it's driven from a silent, fanless aluminum box, which Kramer calls it a mega tool enclosure, but it basically just hides up in a drop ceiling out of sight.
Exactly.
You're taking these massive logistical cabling nightmares for complex commercial setups and just completely eliminating them. I mean, for a current price of $700, this single device is doing the heavy lifting of what used to require a thick bundle of separate, fragile, and honestly highly expensive cables.
Yeah, you used to need separate lines for the network, the video, audio, and physical room control.
Which leaves us with a fascinating question about the future of professional AV infrastructure for you to ponder. We are currently pushing astronomical amounts of uncompressed data over physical, simple copper cables using technologies like HDTV 3.0.
The bandwidth is just staggering.
It really is. So, will wireless technology ever actually catch up to this level of flawless, zero-latency reliability? Or are physical cables permanently crowned king of the professional audio-video world?
It's definitely something for you to think about the next time you connect a screen and just take that pristine picture for granted.
Absolutely. Well, thanks for joining us on this deep dive.